Hello, this is Professor Dan Kernler from Elgin Community College. This video is part of my statistics series. And in this video, we're going to talk about different types of random sampling. All right, let's get to it. So let's first talk about what random sampling is. If we have a question, we want to answer this question, we typically can't look at every individual in the population. So what we want to do from that is we want to select a random and representative sample where that sample is a small enough size where we can actually analyze it, collect data, but then it also represents the population. When we calculate something about the population, we call that a parameter. When we do the same for a sample, we call it a statistic. For example, suppose we talk about the average age of all ECC students. Well, that's a parameter. If we talked about the average age of a sample, say 50 ECC students, that is a statistic. Now, there are two types of statistics. One is descriptive, simply describing this sample. Another is inferential. We're going to try to draw some conclusions about the overall population. For example, the average age of this sample is 23. That's simply descriptive. Now, if we were to talk about, maybe draw some inference about the population and maybe make the conclusion the average age of all ECC students is 23, that's an inferential statistic. Incidentally, believe it or not, the average age of ECC students is actually around 28. All right, first type of random sampling is called simple random sampling. This is where we have some population here. We're going to represent this with these 12 figures. And we'll see, we'll number them. Maybe we'll use a random number generator. Maybe we'll draw names from a hat. Maybe we'll draw ping pong balls, something like that. And we randomly select a sample. Now, this can't be like, I'm going to look at it and pick, I think I want to do number 2, number 5. Like, that's not random. We have to randomize it somehow. The key for this kind of sample is that each of all the possible samples, and we'll learn later on in this course how many possible samples there are, each are equally likely. And again, the way it's done is maybe you draw names from a hat, you use a computer to generate some pseudo-random numbers. So that's simple random sampling. Next, we have stratified sampling. Stratified sampling is used when there's some characteristic about the population that you are specifically interested in getting a representative sample by each of those characteristics. So your population then is naturally categorized in different strata. What you do then is each strata has a different size, and you want to select a proportional number from each of the strata. So here we have our kind of theoretical population size 12, we want to get 4. That means we have to pick 1 from the top, 2 from the middle, and 1 from the bottom. The key for stratified sampling is that your population already has to be split up according to this, whatever this characteristic is that you're interested in. And to select your sample, you have to know how many are in each of the strata. And so you know what those ratios are in the whole population. You just make sure that the ratios of your sample are the same. All right, the next strategy is called systematic sampling. And this is when you have your data all in order. And what you do is you select every whatever one. It depends on your particular sample. In this case, we have a population size of 12. We want 4, so we would select every third. And then we would choose to start somewhere random, and we just have to generate that randomly, somewhere either 1, 2, or 3. And so you pick every third one here. You're sampling every third, and this one we happen to start at number 2. But that would be randomly chosen. The key here for this one is your population has to already be ordered somehow conveniently. Maybe it's an assembly line. Maybe it's people coming out of a doorway, things like that. The way you choose the strategy here is you take your whole population size and you divide by how many you want in your sample, and that gives you your K. That's the every third that we did, or every kth, etc. And then, like I said, you randomly start between 1 and K. That randomizes the order. Now, there is a weakness to this. Suppose you have an assembly line here. It's producing cell phones. And you select every fifth one. Well, what if there's a problem in the process that occurs every fifth, and then you just missed them all, so you think everything's perfect? So sometimes you need to mix up this strategy a little bit. If you have some kind of production process or if there's some kind of pattern to it, you want to make sure that you're not selecting in that same pattern. All right, the last strategy is called cluster sampling. This is when your population is already clustered or grouped together. Now, there are some keys here that those clusters have to be mixed. They have to really represent the population. But if they do, what you can then do is just randomly select a certain number of those clusters. So here we had 6 clusters. We randomly selected 2 of them. That got us our sample size of 4. So again, the key for this one is that your population is already grouped into those clusters, and each cluster represents the population. Then what you do is you randomly select an appropriate number of clusters. ECC actually uses cluster sampling. We do this when we do the Community College Survey of Student Engagement. And if you think about a building here, this happens to be the D building, the math building, you're going to randomly select a certain number of classes. And then you just survey everyone in that particular class. Now, there are some problems with this. Primarily that, remember in cluster sampling, each cluster is supposed to be representative of the entire population, but classes are not. You know, a daytime statistics class is going to generally have students that are pretty similar. They have similar majors. They're probably younger because it's a daytime class versus a nighttime class. So the trade-off then is if you think about your population and your target sample, to counterbalance that, if your clusters have some similarities and they might not be truly representative, just pick a bigger sample, and that will get you a more representative sample that actually represents the population. So what can go wrong with sampling? There are a few things. First of all, you could have an incomplete list. It's called the frame. So your list that you're randomly selecting from could be incomplete, and you're going to miss some people. Second, this is really common with surveying, this is just non-response. People don't respond. So the question then is, are the people who don't respond similar in some way? And that can be really relevant. Third is interviewer error. If you're doing an interview, maybe it's about a sensitive subject, how you're asking the questions, your tone, your posture, that can have an effect on how people respond, how honest they are. So that can affect your sample. Next would be misrepresented answers. This is common when something is self-reported, like your self-reported weight, height, GPA, things like that. When it's self-reported, people may not remember, they might lie, and so that's a misrepresented one. Next is data entry, just actually entering in the data into the database. Something could just be typed in wrong. The next one here is a question type. Say you're asking people's favorite band, and you list 5 options. Well, their band might not be on there. So that's called a closed question. There's only a certain number of options versus an open question. So the type of question might create some errors or some bias in those responses. And then the last one is wording and ordering of questions. We'll talk about this more in another video, but how a question is worded could create some bias where people aren't able to respond in an authentic manner. That's it for this video. Thanks for watching. If you like this, you can subscribe, hit the bell to get notified. I've got more of these videos coming. Also want to thank the Elgin Community College Board of Trustees. They actually approved this video project as part of my sabbatical during the spring 2021 semester. All right, thanks. I'll see you in the next one.